Hey class, this is lesson 3.3 function notation. For the opener, you guys will be spotting and fixing the errors in these two problems. You'll be doing this on our Canvas page. Here's our three learning targets for today. First one, I can use function notation to evaluate and interpret functions. The second one, I can use function notation to solve and graph functions. And then third, I can solve word problems using function notation. Write down all three of these in your notes before you move on. Alright, so a lot of information here. I'm going to highlight the main things. Up to this point, we've only been looking at linear equations and linear functions written as y equals mx plus b. We also, in math, use another piece called f of x, or function of f, known as function notation. And this is simply another name for y. So it's another way we can call our outputs. So our outputs can be called y values, our outputs can be called f of x values. X is the domain, so x is still the input. F of x is simply an output. We could also use other letters like g of x or h of x as well. This is pretty important. So function notation is read as the value of f at x or f of x. It does not mean f times x. So even though there are parentheses here, this is not a PEMDAS situation where you're multiplying. This is simply saying here's an input, the overall thing is the output. Alright, so the first type of example you'll see. So I'm going to go through and highlight a few things here. So the first thing I'm highlighting is this is our actual function. And we're saying evaluate, so plug numbers in when x is 2 and plug in when x is negative 2. So for the left one here, we've plugged in x is 2. Now notice how we write the initial function. We plug in our input. We put our input in our function. We solve the function just like we would a normal simplify and solve problem. And we get down to an answer. So when our input is 2, our output is negative 1. On the right one, same type of concept. We have our input of negative 2, so we plug in negative 2 for both of these. Simplify, get our output, so when our input is negative 2, our output is positive 15. Alright, our next example says, determine what each of these mean in context of this situation. Before we jump into there, just remember a few things. The input is the x value, whereas the entire thing is the output. So this here is input. Okay, so looking back at our problem, if f of x, or f of t, be the function temperature t hours after 6 a.m. Explain the meaning of each statement. So here our value of t is 0, meaning it's 0 hours after 6 a.m. So at 6 a.m. the temperature is 58 degrees. The next one says f of 6 is equal to n. So 6 again is the number of hours after 6 a.m. So this is going to be at 12 p.m. or at noon, the temperature is n. It is not a set value because we don't know exactly what that value is. For the last one, it says that the temperature at 3 hours after 6 is less than the temperature at 9 hours after 6 a.m. Meaning that the temp at 9 a.m. is going to be less than the temp at 3 p.m. This is pretty normal. Remember that this input says how many hours after 6 a.m. So I get this 9 a.m., the first part of this, because 3 plus 6 is 9 a.m. I get this one 9 hours after 6 a.m., so 9 plus 6 a.m. would give us up to 3 p.m. Alright, so this next one, they give us a function, h of x is equal to 2/3 x minus 5. Find the value for x when h of x is equal to negative 7. Now notice on this one it actually says the entire value of h of x is negative 7. So we're saying this entire thing we're not saying that x is equal to -7, then we'd be inputting. That would have been like our previous one in example 1. So we actually need to plug this in like this. -7 is equal to 2/3 x minus 5. We'd solve this like we would solve any other problem. We'd just solve it backwards. So we'd add the 5 to both sides. So we'd have -2 is equal to 2 divided by 3 times x. Times both sides by 3, we get -6 equals 2x. Divide both sides by 2, we get -3 is equal to x. Again, key concept here, if it says the entire thing, so h of x, or the function of h, function of x, is equal to a number, that goes in place of the original piece. So it's equal to the entire function. Common mistake is that people would then put -7 into the x. You do not want to do that on this problem. Alright, so now this one's just going to be more of a walkthrough. If you're told graph a function, you're going to graph it like you normally would. You're going to have inputs, pick a couple numbers, like 5 numbers or so that are all next to each other. Pick the small numbers, the one right around 0, and get those values. You'll plug the x values into the function to get those outputs, and then you simply graph them. Once you've graphed them, make sure you draw a line through, because functions will have lines all the way through them. And then this study tip down here is important. Remember that normally we have x, y values, but if we're using function notation, they're actually going to be x, f of x values, because again, f of x and y are often the same thing. Alright, so this one here. A couple things. This is a big word problem. So like always with a word problem, you're going to want to highlight the key things. So make sure you have a highlighting tool going there. So it says the graph on the here shows the number of miles a helicopter is from the destination after X hours on its first flight. So here we have the first flight, and it's simply saying how many miles. It is from the destination. So it starts at 300, and after 3 hours it is done. So it's going 100 miles an hour. On the second flight, the helicopter is traveling 50 miles further and increases its speed by 25 miles per hour. So the new function, thus is why I'm going to highlight in a different piece, different color. So again, blue is our second flight. We got to compare and see which flight takes less time. So notice how here I'm underlining and I'm identifying what is my actual problem. So we're trying to figure out how long does each problem take. So the first flight took 3 hours to finish because it started 300 miles away. 3 hours later it is at 0 miles away, so therefore it's at its destination. One way to solve this one is to graph it. So you can just simply graph and you can say, okay, at 0 we're 50 miles further, so we're going to be a little bit further away. Then instead of going 100 miles an hour, it's going to be 25 miles an hour faster. So each hour it's going to go down 125. Therefore, you'll notice within this one, our point down here is actually less than 3. So this flight would be faster. Now we don't know an exact number with this. We know that it does come in a few hours, or a little bit of time sooner than the first one. So this one, our time it takes is clearly the second flight is faster, even though it goes more distance. Another way to solve this one is by using algebra. So you can actually say, okay, if we want to get to our destination, so the distance away is going to be 0, we can plug in 0 for our distance away feature, solve it, and we would get down to our exact value. Now this time we actually do get an exact value, which tells us that our amount on the second flight is only 2.8 hours, which takes less. Therefore, the second flight takes less time. Alright, here is the homework for the day. It's a few less problems. It probably won't take you too long to work through. Good luck. If you have any questions, just let me know.